Hi, everyone. I'm very excited to be speaking with you all today. And I'm extra excited to take part of this amazing event, empowering women in tech and specifically in cybersecurity. Hopefully, you're enjoying all the amazing sessions and the great speakers, and you're learning a lot. And I hope that you will learn from this talk as well. So let's get started. Today, I want to talk about how you can build a secured application with cloud native stack, but using open source security tools. And building a secured application or even securing an existing one could be a very difficult task. There are so many factors that you need to take under consideration, and you just don't know where to begin with, right? Where to start. And so I hope that this talk will kind of help put things in order. We'll see at the end. Before we dive in, I want to do a quick introduction. So my name is Raz Probstein. I'm a solution engineer at JIT. I've actually been a full stack engineer for many years, and I've joined JIT a little over almost 2 years ago. Yeah, almost 3 years ago as a full stack engineer. But after 8 months at this position at JIT, I've decided that I want to do a little bit of a shift and become a solution engineer. So I'm very happy about it. I'm also studying for my bachelor's degree in biotechnology. So I'm a biotech advocate. I'm a big foodie, and I love to travel. So that's about me. And I also want to tell you a little bit about JIT. So JIT is an open ASPM platform. We're basically helping modern dev organizations own their application security without hurting the dev velocity. We're automating the best of breed open source security tools, and we're integrating security across the entire lifecycle. So, code, infrastructure, CI/CD pipeline, and the runtime as well, with little to no effort. So that's about me and about JIT. And now we can really get started. All right, so before we start talking about how to secure the application, we need to understand how it is built. Now, if you ask a 3-year-old to draw a sketch of an application in the cloud, I'm guessing this is what they will draw. Well, they're not wrong. It's just, missing a few details. But we'll get into those details in just a bit. Now, if I'd ask the same child to draw how to protect the application in the cloud, I'm guessing this is what it would look like, which again, is not completely wrong. We do need to protect the perimeter, but it's not that easy, right? So let's discuss how the perimeter is built. So this is a rough sketch of our perimeter. We have the CI/CD pipeline that constantly communicate with our cloud environment. We have the cloud resources that are publicly accessible, like the public IPs, the S3 buckets, and so on. We have third-party services, and we have users who access the application itself. Right? So now we've basically mapped the potential weak links. But what do we need to do in order to make sure that our perimeter is secured across all those threat points? So for the user access, we need to implement the least privilege principle, and we need to make sure that we enforce MFA for all the users. For the CI/CD pipeline, here as well, we need to implement the least privilege principle. For the public resources in the cloud, we want to have cloud misconfiguration detection, and we want to implement pen testing as well. For third-party services, we need to have MFA, and we need to define and provide only a required scope of permissions. Now, for now, we're just mapping the action items that we need to take, and we'll get into the actual implementation in a few minutes. Now, protecting the perimeter is not enough, right? We need to look into the app itself. So we're looking into the application. We have quite a large potential attack surface. So now we need to map the potential attack points and list the action items that we need to take. So we have the actual data traffic, right? We have secrets that cannot be disclosed, the access to services that needs to be done in a secured way, and we have all the third-party libraries that we need to protect as well. So what do we do with it? Those are the high-level action items here. We need to make sure that our data traffic is encrypted. We need to manage and monitor all of our sensitive data, such as secrets. Again, we need to work by the least privilege principle, and we need to scan all of our third-party libraries for known vulnerabilities. And of course, we need to have constant logging and monitoring in order to protect our application. Tiny break. So we've talked about the perimeter and we talked about the app itself. And we can all agree that there is a nice amount of action items that we need to do in order to protect our application. But how do we actually do that, right? So let's dive in. I think we can start, taking a look at this from a more detailed perspective and no longer like a 3-year-old. So this is how things actually look like. Definitely more detailed. And now we can talk about how to implement some of those action items that you see here. And you can see that it's divided to protecting the boundaries and protecting the actual data. Great. So let's start. The first action item is detecting code vulnerabilities. And our mission here is we need to use code scanners to identify vulnerabilities and security defects in the code when we are writing it. And I recommend open source SemGrep. It's a great SAST tool. It has a very extensive rule set and it supports many languages, so it's good for us. We need to detect hard-coded secrets as well before they're being merged to main and deployed to production. This is our second action item. I highly recommend using GitLeaks. This is an open source tool. It supports multiple types of secrets like API keys and AWS credential and SSH keys and many more. And it has support for detecting the secrets in the Git history as well. So it's good. We want to make sure that we detect everything that we have existing in our GitHub. Moving on to the dependencies here. So we need to detect publicly disclosed vulnerabilities in the various components that we're using. And if we can get an SBOM as well, this is a big bonus. I highly recommend the OSV scanner tool. This is an open source tool that is maintained by Google and it's supporting most of the package managers. We can also specify the scan to specific SBOM and log files, which is great for us. We want to have this ability to customize. Now we're moving on to protecting our infrastructure. So this is part infrastructure, part code security, because we need to detect security misconfigurations in our infrastructure as code before they reach the cloud. So we're shifting left here. My recommendation is Kix. Kix, this is a great open source tool. It's by Checkmarx. It's supporting many infrastructure types like CloudFormation and Terraform and Kubernetes and Helm and Docker and ARM, serverless, you name it. It's a very good tool. And it includes over 2,000 checks. And this is a lot. This is a massive amount. I'm moving on to protecting our pipeline. So, vulnerable container images. Our mission here is to detect vulnerabilities and configuration issues in the container images. And Trivy is a great tool for that. It's an open source tool by Aqua, and it supports container scanning and file systems and Git repositories and VMs, secrets, and infrastructure as code as well. Just inside info. So this is definitely a tool to consider. I'm switching back to protecting our infrastructure because this is part infrastructure, part runtime. And this is cloud runtime misconfiguration. And our mission here is to detect misconfiguration in the infrastructure, all the resources that are already running in our cloud. Because it's not enough that we're scanning just the infrastructure as code. Things can be modified and altered after they're running, right? We have people who are accessing our cloud environment who can affect the resources after we deploy it and start running them. And Prowler is a great tool for that. It's an open source tool that supports AWS and GCP and Azure, and it's very strong and very comprehensive. I really like this tool. The results are provided in a very readable output. So this is a great tool. Now we're going to talk about the pen testing, DAST, the dynamic applications. So our mission here is to stimulate attacks on our front end to make sure that it's safe. We want to make sure that no hacker finds vulnerabilities before we do. So let's simulate all the possible attacks to make sure that our application is not vulnerable to that. I highly recommend Zap. Zap is one of the most powerful open source pen testing tool that exists out there. It has many features and many extensions. It has a marketplace that you can find over 100 extensions today, so it's very extensible. You can run it everywhere, including a desktop application, and this is very unusual to open source tools. And you also have a headless mode to integrate it into the CI/CD. So this is another layer of security if you want to run the pen testing, the desk scan, while deploying, right? Scan on deployment. It's another shifting left. And for the final item that we'll cover today is the multi-factor authentication, MFA. Our mission here is to make sure that all the third-party access have MFA enforced, and we need to detect those who do not use MFA. For example, GitHub and AWS, we need to have MFA access enforced there. For this one, I'll be honest with you, we created custom tools for the MFA checker for GitHub and another tool for the AWS check. There are tools that exist, but we really like the tool that we've created. It's very strong, but you can choose for yourself. All right, so another quick pause. And what are the takeaways so far? Like, how can I secure my cloud native application using open source tools? We have all those tools now. We have for SaaS, we have SendGrep. For the SCA scan, the dependencies, we have OSV scanner. For the secret detection, we have Git leaks. Container scanning, we can use Trivy. For DAST, Zap is a great tool. For infrastructure as code, Kix is my recommendation. For cloud native, for the cloud security scanner, I recommend Prowler. But again, we're left with a question where to begin. We have a lot of tools, but what now? Well, in order to not reinvent the wheel, I would advise you to start with a security framework. Define where you want to be. What is your goal? Where you want to be at the end of the quarter and the end of the year, and work from there. I'll be showing you what I like to call the MVS plan, the maximum viable security plan. But there are other good frameworks or checklists that you can use in order to protect yourself, like the SOC 2 or ISO or OWASP Top 10 for serverless. You have it for other frameworks as well. Those are just some examples. I will cover today the MVS plan, and we'll start with it. So we're starting with the first part. I divided the MVS plan into part 1 and part 2. Now, you can see here that it's divided into categories as well. So we're starting with securing the code. This is the first step that we need to take, right? So the code vulnerability detection, the secrets detection, the detection of vulnerable libraries, logging. Then we move on to protecting the infrastructure, which is the cloud misconfiguration. Part of both is the infrastructure as code scanner and implementing the least privilege and principal versus like remote access. Now we can move on to continue and implementing our runtime security. So it's the pen testing and API security, the DAST basically, Zap. And for the final step of the first part is securing the pipeline. So vulnerable containers, and again, least privilege. Now, if you're happy with your progress on the first part, we can move on to the second part of the MVS plan. Now we move on to securing our data encryption and making sure that the secret storage is protected and we're doing it in the right way. Then we move on to the third-party services, right? We need to make sure that the access is secured. The next step would be around your people. The people in the organization are also a potential attack surface. Those are the weak links as well. We need to make sure that we're covering, the passwords, that we're managing and securing the passwords that we're using, for example. Finally, we can get to securing the operations, audits, making sure we have backups. So how do we actually make it work? And I want to tell you that I believe that this is a joint effort. This is a joint effort between the security team and the engineering organization at the company. The security team needs to configure the tools to implement them to the SDLC. We need to make sure they're implemented in the CI/CD. You need to maintain the tools and they need to manage them. But the engineering team need to take responsibility and use the tools that the security team implemented in order to write secure code. We need to make sure that developers know that securing the product is part of their job, just like making sure that they're not introducing a bug to production. And the most important part here, that it does not stop at the CI. We need to make sure that developers are helping fixing the existing vulnerabilities as well in the repositories that they're in charge of, part of their responsibility, not just what pops up in the pull request. Remember, security is not a one-time checkbox that you can just check and move on. This is a journey, and you need to constantly monitor your application, constantly monitor your environment, make sure what's the new and upcoming attack surface. We need to add more security probably. So just continue to monitor. How we can take it to the next level. So we can all agree that there is a heavy lifting that needs to be done in order to actually protect our application, specifically from the security team side, but also from the development team. So from the security team, they need to, map the needs, find the tools to suit those needs, learn how to configure and implement the tools, integrate the tools into the SDLC at every step of the SDLC, right? Because we have the code, we have pipeline, we have the runtime, constantly securing the SDLC. Then they need to maintain and manage the tools. They have a big backlog of vulnerabilities to handle. And the most difficult part for the security team is to get the developers to work with the tools. There is also a big gap for the engineering. They don't know what to do. Most likely, the tools that you are choosing, it's not similar to what they know or what they used to work with. It takes them out of context. It's hurting their velocity. So you need to find the right balance. You need to find the right way to work. And in order to really take it to the next level, you need to automate. You want this process to be as automated as possible because it's not scalable for the security team to do all those things by themselves and for the engineering team to learn how to work with all those different tools. And again, automating is easier said than done. We've seen that this is a lot. So I want to share with you how we made it super easy for ourselves and how we implemented an even bigger security stack to make sure that we're covered from day one across all the product layers. But for us, what was most important is that we implement security while creating a culture of all hands on deck. Everyone is responsible, the shared responsibility. So I want to show you what we've done. So this is kind of our structure of our product that we're using. Okay, so this is the OpenASPM for the cloud applications. So we basically built a framework. We basically built an application that maps your security goal with your business goal, right? We've talked about defining where you want to be. What is your goal? Define the framework that you want to work by. So instead of us working on those frameworks in spreadsheets or PDF files like the SOC 2 or ISO or the OWASP Top 10 or the AWS FTR, for example, we don't want to work with spreadsheets. It's not scalable. So we've created automated security plans while implementing the shared responsibility model. So in our organization, we've created a security portal, right, for the security team, allowing them to easily and very fast roll out all the security framework, all the security tools, while defining KPIs, monitoring them, exporting the reports, and managing the overall security posture. For the engineering organization, we've created a team portal. Everything is being done to drive adoption. So the engineering are viewing the results, the scans in their natural environments, which is the IDE, GitHub, GitLab. We're not taking them out of context. We don't want them to learn new experience for every tool or learn a different UI. Everything is being done in their natural environment. And for the team leaders, we want their help solving the existing vulnerabilities, right? The existing security gap. We want to improve our security posture. So for them, we've created a team portal that they can look at their own backlog. What are the vulnerabilities that I'm in charge of? We're doing all of this by the open orchestration framework for the security tool. So we're basically orchestrating the best of breed open source security tools across all those different type of checks. So application security, cloud security, the runtime, the DAS, and also the CI/CD security. And everything is being done by us, all the heavy lifting. So our framework basically does all the hard work. The configuration, the implementation to the CI/CD is being done by our product. And now all there is left is just to manage, start to work with JIT. And in order to not make it so difficult to handle the existing security gap, the giant backlog of vulnerabilities, we've created a context engine that is AI powered. We're basically adding context to our vulnerabilities. So we know which vulnerabilities are top of mind to fix today. We don't want to handle thousands of vulnerabilities every day. So we want to know what is actually exploitable, what is actually publicly exposed, what is actually deployed to production. And those are the items that I want to fix. So this is very little about what we've built for us. And if this is interesting for you and you want to know more, please check out our website, jit.io. And if you want help implementing your own security framework, or you want help implementing security tools, I'm here and I'll happily answer any questions you may have. It will be offline since I'm not there in person, but please reach out to me. This is my email, you have it here, you have my LinkedIn, you have my X or Twitter, whatever you like to call it these days. So please reach out to me. I look forward to hear from all of you. I'm happy to help all the women in our community. So thank you so much for the opportunity to talk with you all today. And thank you everybody for your time. Enjoy the conference.